Okay, before we actually get into the problems, I do want to talk about these two concepts of there's actually two ways that we can write quadratic functions so that when we graph them, we get the information of how to graph them in different ways. You can always just make a table of values for whatever form it is in and whatever it has, but a lot of times we have certain ways of writing it that make it easier, just like how we kept going to slope-intercept form because that was the easiest way to graph lines. So here we have two forms, vertex form and standard form. Vertex form is laid out so that we can see the vertex. That's why it's called vertex form. That's helpful because what we need to be able to draw a parabola is we really need to know what the vertex is. Even if you're going to make a table of values, it's still best to think about what the vertex is first so that you know what numbers you should pick for the rest of your table. Because if the vertex is over at like 5 and you start your table of values at 0, it's gonna take a while before you can see the parabola pattern. So that's what is neat about vertex form. And don't get too distracted or excited about my laser pointer thing, which is a lightsaber, but you'll notice that inside here is -h, and that's similar to what we had with like point slope and things like that. What is inside this parentheses here, whatever number this is, like if it's a +2, we take the opposite sign of it and put it right here for the vertex. So these are some things that are consistent about functions, that because this is inside of a parentheses, x minus h, and our function is being squared, anything happening on the inside of our function, for one thing, is happening directly to x, so it's affecting things horizontally, and then it's opposite of whatever you might normally think it is. So with that example, if this was x plus 2, and you know it's supposed to move horizontally, you might want to move it 2 to the right because that's positive 2. But because it's in parentheses, it actually works backwards. And it's actually part of the, I don't want to say it, but I probably already did in class. So it's part of the super secret opposite society. Anything inside of our function, so anything inside the squared, is going to affect things horizontally, and it's also going to affect it in the opposite way of things that are outside the parentheses. So for instance, this plus k is not going to affect x, it's actually going to affect y. Because if we were doing a table of values, we'd figure out all of this, and then we'd just add this number at the end. So it's basically just making us move up or down, and it's not part of the super secret opposite society. So if it's +2, it will move up, and if it's -2, it'll move down. So we can grab the vertex just from this part and this. We also have this variable a in front, which would be a number, or maybe not even there because it's actually 1. So this number is going to tell us which direction the parabola opens, because positive is up, negative is down. And it's also going to tell us how fast or how slow our parabola is going to go up or down, like what we did with the monomials last week. Now, if the whole point of what you're doing is to graph something, vertex form is the easiest way to graph it. But if you're actually talking about like a real world situation with, throwing something or launching a rocket or something like that, you're actually going to be in standard form most likely. And we'll talk more about that later on and how that all works. But when it's in standard form, this is the same kind of standard form that we've already talked about with like the quadratic formula. We just have it equal to y instead of equal to 0. In this, you can't see the vertex right away. You actually have to use this formula here, negative b over 2a, to be able to find the x value of the vertex. But what's cool, in my opinion, is that once you have that vertex and you plug it in and get the y value as well, then this a in front of x squared does the exact same thing as this a in front of our parentheses. It tells us the direction it opens, up or down, and it tells us how fast or how slow it goes up or down. So, like I said, you can use a table of values. It's absolutely an option. But if we can memorize the pattern of parabolas, which is that we start at our vertex, and then we go, this is going to be poorly drawn probably, we go out 1, up 1, and then out 2, up 4. And then we do the same thing on the other side, out 1, up 1, and then out 2, and up 4. And if we wanted to keep going, we could, because we could go out 3, and then that would be up 9. But this is the shape that a parabola takes. We can make it stretch or shrink or be upside down, but it's still going to have this pattern happening to it. And we're going to look at that in detail. This is just kind of the starting info that you need.